Okay, let's start working on assignments. Two variables have a positive linear correlation. Does the dependent variable increase or decrease as the independent variable increase? So choose the correct answer. Dependent variable increase or decrease as independent increase? Yes. Okay. Well done. Next question. Because remember we said if the positive one correlation, when x is increasing, y is increasing. Negative one, x is increasing, y is decreasing. Okay. Next one. Describe the range of values for the correlation coefficient. The range can be from -1 to +1, inclusive. Okay. I would recommend you to watch the lecture for these definitions. All right. Which value R indicates a stronger correlation, 0.778, or R is negative 0.919. So absolute value, by absolute value, 0.9119 is stronger. But because it doesn't say positive or negative, it just say correlation, then I would choose R is equal negative 0.919 because it's stronger, closer to -1. So it's going to be negative 919 represent a stronger correlation because 0.778, no, that's not the answer, it's wrong. Represent a stronger correlation because absolute value of negative 0.919 is greater than 0.778, that one. Fantastic. A strong negative linear correlation has an R close to -1. Strong positive one has close to 1. A weak linear has close to 0. Because negative 0.919 is closer to -1 than 0.778 close to 1, then just like I explained, by absolute value, 0.919 is greater than 0.778. Because it doesn't say positive or negative, then the 0.919 is stronger. Okay. Discuss the difference between R and rho. Whoever watched the lecture is aware that R represent sample correlation coefficient. Rho represent population correlation coefficient. Okay. Next. For the following data, display the data in a scatter plot, calculate the correlation coefficient, and make conclusion about the types of division, types of correlation. Okay, and sometimes you can look at the data and figure out, although we will go through the stat crunch, but let's see. So age is increasing from 1 to 6. Let's see what's happening to Y. 200, 1100, 13, 14, 16, 20, 25, 20, 2250. So as you can see, increasing. So it's going to be increasing correlation, positive correlation. And with exception of 20 to 50 is much high, far away. Now it's going to be, instead of A, between A or C. How are we going to find out? Let me see 2250. This is age, vocabulary size. Oh, I see. Vocabulary size is going as independent value as an x, which is wrong. Vocabulary size is y. It has to be as a dependent. which I'm choosing A. So we have here 200 right here, the lowest one, and then goes as a straight line, and 20 to 50 a little bit further away. So let's also double check with StatCrunch. Okay, first time it's always hit the error. Second time it goes, I don't know what it is. All right, so we have age, we have vocabulary, X is independent, vocabulary, Y is dependent. So we are choosing graph. And where is my scatter plot? Here is scatter plot. So X is an age, Y is an vocabulary. That's all we need. So we are clicking, I'm clicking my compute. See, we got exactly what I had. All right, let's close it. And now let's check it. Bingo. Oh, correlation coefficient. Okay, let's go after correlation coefficient. Stat. Where is it? ANOVA regression here. We are clicking on regression, and we are choosing simple linear regression. Our X is variable, Y is vocational side, and we are going through compute. There we go. Correlation coefficient. Where is it? Dependent X, independent, oh, here it is. Correlation coefficient 0.94. I can't write down it. I don't have, it's not in editing mode, so I can't write down. Here it is. It's after below sample size 6, correlation coefficient 0.9437. Let me write down so we can fill out. 0.9438. 9438. Let me round till 40 digits, and I don't know how many it's asking. Now here, it's what is interesting. If you choose stat and regression, click next page, and you will have your graph. Okay, here it is. Scatter plot graph. All right, going back, closing. Back to here, correlation coefficient. I'm going to put how many? 3 decimals. So it is going to be 0.9, where was that? 944 if I round it up. 0.944. Okay. Nice work. That's it. Continue. Oh, okay. So what do we have? Which of the following been describing the type of correlation that exists between age and vocational? It looks like, let me see, no linear equation. It's not, because it is linear. Strong negative, it's not, because it's growing, right? And a strong positive. Strong negative, weak negative, weak positive. It's not a weak, I would say strong positive. And based on correlation coefficient 0.944, that's witnessing strong correlation coefficient and strong positive linear correlation. Bingo. Next question. So what is this? The following data display a scatter plot. Calculate the sample correlation coefficient. Make conclusion. Okay, we need to choose the correct scatter plot below. So I'm not going to guess here anymore because it's mixed kind of. So we are going to open StatCrunch. Stat. We go regression after variance, choosing simple linear. This is, we have maximum weight. This is, we have y is our time, and we click compute. Okay, correlation coefficient R is negative. Let me write down. It's gonna be negative 0.95. It's a strong negative, right? Correlation. Negative 0.952. Okay, now we need to check a scatter plot. Okay, strong negative based on, well, yeah, 0, negative 95. It's gonna be strong negative correlation. Closing. So this is also closing. Typing in, this is gonna be which one, guys? Strong negative. Looks like this is looks more a strong negative. C is like a chaos. D is a chaos. It doesn't have anything. Max is a very weak correlation coefficient. So let's check this one. Excellent job. Correlation coefficient, typing in negative 0.952, negative 0.952. Excellent job. Moving to question number 6. What do we have? Since negative 952, it's clear that it's negative. We have strong negative linear correlation. Guys, I have here correlation coefficient different number because the software dropped my MATLAB, so I had to open different case and fill out, okay? So that's all, but the answer is the same. So moving on to next case. Let me see. Question number 7. Use given data set to complete parts A through C. Okay, alpha is equal 0.05. First, we need to construct scatter plot. Okay, we will construct. That's not a big deal. We already know how to construct, right? Okay. But instead of going through graph, I'm just opening regression because I'm pretty sure there will be some other data also important. Then we just open it and just follow the questions. Why? Okay, compute. Okay, going to second page. Yeah, we have non-linear. See, it's going like parabola, negative parabola. So let's choose it. Which one is it? C, right? Let's check. Nice work. Now let's see what they want next. R, linear correlation coefficient. Going back here. Okay. Correlation coefficient is negative 81, negative, oh no, positive 0.817. 817, okay. Zero point 817. Nice work. Okay, well done. Do we have anything else? Next, using linear correlation coefficient found in the previous step, we need to determine whether there is sufficient evidence to support the claim of a linear correlation between these two variables. So what we are going to do here, we're going to open this table of critical value. How much is our n? Our n is going to be, let me see. So let me see how much we have. Let me close this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have total 11, alpha 0.05. So 11 and 0.05 is 0.602. Let's write down 6 0.602. So it's gonna be 0.602 plus minus, right? And how much is our linear correlation coefficient? 0.817. 0.817. So our R is greater than our critical value, R critical, and this is our R. So it's greater than R critical. That means there is correlation, right? So let me see. We can say that there is, well, I can't get rid of the answer, they already placed it, but looking at the fact that our R 0.817 is greater than 0.602, right? Critical value we found. It's evidently there is sufficient evidence to support the claim of linear correlation between the two variables. Okay, now you would wonder, how is it sufficient evidence of a linear correlation between two when you have here as a parabola? The question is true, but let's see. There is it says linear, doesn't say positive or negative. Up to y is equal 9, right? And x is equal somewhere 10. It's going positive correlation, right? Straight line. Then it's going negative correlation. Let me show you here. So it goes like this, right? And then goes like this. So you can provide positive one correlation and then coming negative one, right? Okay. And the last question, identify the future of the data that would be missed if part B was completed without constructing. Okay, part B is which one? Without constructing. Okay, the scatter plot. Choose the correct answer below. The scatter plot does not reveal this distinct pattern. The scatter plot reveals distinct pattern that is not straight line pattern. That is true, because it always shows where is a straight line or is not straight line. In our case, the whole scatter plot is going like parabola, right? But if you break into two parts, positive correlation and negative correlation, which means the scatter plot does not reveal, that's not true. The scatter plot reveals a distinct pattern that is a straight line pattern with positive slope. That's not true. It shows and positive and negative, which means neither C nor D cannot fit. The only answer fit is B, where scatter plot reveals distinct pattern that is not a straight line pattern. Okay, moving to next question, number 8. What do we have here? It's gonna be same way, you already know, right? So I can open here, start crunch. So where is it? Regression, simple linear, X, Y, compute. Our scatter plot is showing straight line, right? It has here a residual a little bit, but it's a straight line. And if we go back, we need this, right? It's gonna ask us correlation coefficient, and that is 0.812. 0.816, I'm sorry. Where from? So we chose B because it's a linear correlation, And moving to next question, question B. And next question we need to answer using the linear correlation. We need to, okay, bottom line is we need to read the choices and find out which statement is true. But to answer that question, first we need to take critical value, right? So for critical value, we need sample size. Let's see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 elements. 11 elements in the 0.05. It's going to be 0.602. And 0.816 is greater than 0.612. Therefore, there is sufficient evidence to support the claim of linear correlation. We are testing linear correlation between the two variables. That's going to be D. Good job. Okay, next question. Identify the future of the data that would be missed if part B was completed without constructing the scatter plot. Practically asking what would be the future of data if we wouldn't have to go through scatter plot. So in this case, the scatter plot reveals the perfect straight line pattern except for the presence of one outlier. Excellent. Moving to next one. Okay, what do we have? Do the data appear to have a strong linear correlation? Do you think they have strong linear correlation? I don't think so. There is no linear correlation. It's a rectangle there, the whole rectangle. If you don't believe me, you can go to the scatter plot, get correlation coefficient. I guess we will have to, we'll see. No? Excellent. What is the value? Actually, these questions we already know. You can answer, right? Correlation coefficient for all data points. You have to find critical value and compare if this R will get, let me see. If this R we will get, okay, it doesn't show here now. If R doesn't get greater than our critical value, then you have linear correlation. Then you have linear correlation. If it's less than, there is no enough evidence to insist that there is a linear correlation. Okay, I'm getting the answer. I'm just putting something so just to move on, see if there is other question. Okay, third time. All right, we got it. And so the same question, yes. All right. So moving to number 10. Yeah, those are all the same questions. Let's do this one. Okay, 11. This is gonna be the same, I believe. Let me see, yeah. On null hypothesis, test statistics. Okay. This one already using test statistics. So, although the answer's there, but who cares? We can get the answers ourselves also. So, we need, more importantly, we already know how to find out correlation coefficient. We will do that. But I would like to focus on null hypothesis, null and alternative hypothesis. So what do we have here? Listed below are numbers of internet users per 100 people and numbers of scientific award winner per 10 million people for different countries. Okay, find p-value, determine sufficient. So if it says for different countries, then it's going to be equal, not equal. Raw correlation, right? So we are going to get test statistics, p-value, and correlation coefficient. All right, let's go get it. StatCrunch, regression, simple linear, and here we have this one, x, here we have y, and we are getting compute. Okay, so let's write down what do we have. So our correlation coefficient, I have 0.781, it's right here, I'm zooming. R is 0.781. Next, actually, if you round 0.782, next we are going to take the t-stat. It's going to be where our slope is, 2.51, and the p-value is going to be 0.06. I took the information for the slope because that's going to be our information. So moving back to our assignment. Where is it? Oh, here it is. 2.1 and 0.66. Yeah, we filled out. Okay. And when it says p-value 0.066, so what do we have? Our p-value is the greater than significance level, right? Or not? Oh yeah, it's greater. P-value 0.066, alpha is 0.05. Because it's greater than significance level, then we can say there is not sufficient. So when it's greater, then we fail to reject our null hypothesis. If we fail to reject null hypothesis, then we reject alternative one, right? So since we reject alternative hypothesis, then we say, because the p-value of the linear correlation coefficient is greater than the significance level, then there is not sufficient evidence to support the claim that there is a linear correlation between internet users and scientific award winners. Okay, not to repeat the same thing over and over, same problems, I will keep the answers completed and we move and see if the questions are identical, then we move on. If the questions are different, then we stop and I will go over, okay? Number 11. So let me open all. Okay, it doesn't show me. I guess it's not the same anyway. We have alternative and null hypothesis we need to build. Okay. Listed below are amounts of court income and salaries paid to the town justice. All amounts are in thousands of dollars. Construct a scatter plot, find the value of linear correlation coefficient, and find the p-value using alpha. Well, same thing we already did. Well, that's okay. We will build it. Using alpha equals 0.05, is there sufficient evidence to conclude that there is a linear correlation between court incomes and justice salaries? Okay, our alternative and null hypothesis is going to be D, because we are in this topic we are going to test the two-tailed test, because it's either there is correlation there or there is not correlation. Okay, that's all it is. That's why it's always going to be double tail. Okay, and we know that it's fantastic. Okay, so to construct StatCrunch, again same thing. where is it? Regression, simple regression, this one, just this, compute, and let's write down before we get scatter plot our correlation coefficient 0.861, and then t-stat for slope, that's what we need, 4.477. I'll round it up if it wants two decimals, I don't know right now, and p-value 0.0029. Okay, and our fitted line, our line is okay. So we are getting where is it? This is my stat. Here it is. Do the homework. So it's gonna be linear, which is gonna be D. And next coefficient, correlation coefficient, it's gonna be 0.861. Okay. T critical is going to be 4.477. How many decimals? 3. Okay. 4.477. Okay. And then p-value is 0. How many decimals? 3. 0, 0. Okay, 0. P-value is going to be 0.002. Okay. We are done. So now we need to draw conclusion, because p-value is less than, right? We have less than, because p-value 0.002 and alpha 0.05. So we have, because it's less than, then there is sufficient evidence to support the claim, right? Because it's falling in healthy area, two tails. Sufficient evidence, here it is. Two tails, right? 0.025, 0.025, and our alpha is 0.002. Since 2,5, this is going to be negative, so 0.002, it's right at the edge, right? Therefore, we can support. So there is sufficient evidence and blah, blah, blah. Okay. And our correlation coefficient is pretty strong, 0.861. Then we can say that it does appear that justice might profit by levying target fines, because it's a strong correlation. Oh, I chose doesn't appear. Okay. It does appear, might profit, it does appear that justice might profit by levying larger fine. Here it is. I'm saying doesn't, choosing doesn't. Okay. Moving question number 12. Which of the following is not true for hypothesis test for correlation? Okay. If p-value is less than or equal to the significance level, we should reject null hypothesis and conclude that there is sufficient evidence to support the claim. That is true. If the second one, if the p-value is greater than significance level, we should fail to reject null hypothesis and conclude there is not sufficient evidence to support the claim of linear correlation. That is also true. if R is less than critical value, we should fail to reject the null hypothesis and conclude that there is not sufficient evidence to support the claim. That is also true. Okay, well, I guess we have left D as not true. Let's see what it is. If R is greater than critical value, we should fail to reject null hypothesis. That is just not true. If it's greater than critical value, then we reject null hypothesis. Fantastic. Okay, question number 13. All right, here we are going to complete predicted value. So I don't even need to read the entire question because I'm looking, we have a format of y is equal mx plus b, or written down b plus mx, doesn't matter at all. And we are going to get here let me see. We have these two form one is x, the other one is x bar. We don't have x bar, it's gonna be x, this one, a. So let me write down, because y bar is equal slope at the intercept plus slope times x. Our intercept, it says negative 374. Negative 374. And our slope is 120. This is whoever remember algebra well. Oh, negative 374. Okay, and now we're moving here. It's 120. Fantastic. Okay, moving to next one. Question. What does the symbol y hat represent? The symbol y hat represent the predicted value of price. Where is it? Oh, here it is. We are good. So moving to question number 14. What do we have here? What is the difference between following two regression equations? Well, if you remember regression line, lowercase b0 and b1, where b1 is the slope and b0 is intercept, that represents sample. And at the uppercase b0 and b1, that represent intercept and slope for the population. So the first sample is first equation is a sample, and second one is a population. Number 15. Okay, so what is residual? Okay, residual is a difference between y and predicted value. Y bar is a predicted value, and y it's our real value of y on a scatter plot. So residual is a value of y minus y bar, which is the difference between observed value and the predicted value. That's what we call residual, which is mistake. And the second question, in what sense the regression line, the straight line that best fits the point in a scatter plot? So the regression line has the property that the sum of squares, that's a sum of residuals, squares of the residuals is the lowest possible sum. That would be best fit. What does that mean? Shortly saying, the smaller is the mistake, error, the closer to the reality the prediction is, right? That's just the logic if we use. Question number 16. Oh, check. Question number 16. What do we have here? Suppose IQ score were obtained for 20 randomly selected sets of couple. The 20 pairs of measurement yield X bar is equal 99.09, Y bar blah blah, and R is equal 0.877. P-value and everything else is given, where X represents the IQ score of the wife. Find the best predicted value of Y hat given that the wife has IQ of 94. Use significance level 0.05. So this one, we are not going to just copy and paste. There's a prediction value, just like we did from the previous one. Here we are going to do some math. So it's asking the Y bar predicted value given that the wife has an IQ of 94. And our equation for predicted value is 1.51 times 1x. I might as well could put x. So 1.51 Y bar is equal 1.51 plus X. And we said it was 94, right? The value. Yes, 94. Okay. So let's do math. So it's going to be 1.51 plus 94. That's what it is. It's going to be 95.51. So it's going to be 95 point, how much I said? 51. Okay. This is question number 17. Do we have everything identical? Let me see. So yes, it's going to be exactly same problem, similar problem as the previous one. So we need to find the best predicted value for the adult male who is 155 centimeters tall, and our Y bar is equal negative 105 plus 1.18x. So we are going to, instead of x, plug 155. So it's going to be negative 105 plus 1.18 times 155. Let me see. 1.18 times 155 and plus, okay, negative, subtract 105, and we are getting 77.9. Let's see what we get. 77.9. Why is it incorrect? What did we do wrong? One more time. Math must be wrong. 1.18 times 155. Okay, 182.9 minus 105. 77.9 kilo. I picked similar one. Let's see, 1.15 times, what do we have, 139 and minus 103, 56.85. Nice work. So which means the previous one was maybe calculation, their calculation was wrong. I don't know. Moving on, because I know I'm doing right thing, right calculation. Okay, question number 18. So it's all same things here. You can do it. You need to find the regression an equation, or yeah, regression line, and then scatter plot will come, so you can do it. So I'm moving on to number 19. Let's see, what do we have here? It's same thing, you can do it. Number 20, it is also absolutely same thing. So y hat, let's do this one. Okay, so we are going to get here from StatCrunch equation. We will get from here equation, regression. This is simple linear regression. This is going to be first one, second one, combined. What is our regression equation? Here it is. It's going to be negative 32.1. I'm rounding till one decimal because they require one decimal, and plus 11.31, 11 point and gonna be 3 times chest size is gonna be our x. Okay, so going back, where is it? Oh, here it is. So negative 32.1 plus 11.3 x. Okay, so what else is in there? The best predicted weight for a bear with a chest size of 51. So with 51, we are going to plug into our predicted value, just the same way we did the previous one that was keep saying it's wrong. Let's calculate this time same way. So 51 times 11.3, that is equal 576.3, and minus 32.1. It makes 500, what? One more time. 11.3 times 51, 576, and minus 32.1. Yeah, got same answer, 544.2. Okay, good job. So it indeed was something wrong with that math there. And the result, is this result close to actual 505 pounds? Well, 505 and 544, I would say they are not close. So the result is not very close to the actual weight of the bear. Everywhere it says very close, close, or exactly, it's none of them will fit, so it's not close. Okay, so number 21, it's gonna be same thing, so you can do it, right? And moving to number 22. Let me open for 21 answers, so if you want to try to do it, you will get the answer. Okay, now 22. Okay, I believe it's the same thing. So you can fill out the regression equation that you can take from the StatCrunch. Okay, okie dokie. Let me open just in case if you are interested. Well, in this time it's not showing. Well, it's a software, it does whatever it wants and nobody can do anything. All right, see you in next video.